So hey guys, we're doing the biochar presentation group. My name is Nate Jacobs.
I'm Paul Leeds.
And Avi Grant.
So just some background information to get you started. Biochar combats climate change using a support sink method. And what this means is that it buries atmospheric carbon dioxide into the ground through sequestration. And not only does this sequester the atmospheric carbon, but it also can enrich the soil itself. And how biochar is made is that it is biomass, which is slowly baked in the presence of oxygen. And this process actually retains most of the carbon found within the biomass, which further emphasizes the sequestration capabilities that biochar has. And biochar is generally, it can be made from any biomass, any waste material we have, the most common ones being peanut shells, rice straws, and wood scraps.
So Biochar Works is once you have the biochar, you apply it to the surface of soil, or you can mix it into the soil. And this can have varying effects, such as changes to the pH, density, or water retention capabilities of the soil. This can address global change because it can improve the soil's ability to store water. Biochar has a high surface area, so water sticks to it, and this can be beneficial in drought or dry conditions. And biochar can also increase soil's fertility, which can promote more efficient plant growth. Lastly, as Nate said, it can act as a carbon dioxide sink, and this can potentially lead to a carbon dioxide negative situation.
So benefits of biochar include it saves money that would have been spent on irrigation systems. According to an article from Rice University about a study in biochar that was led there, in the best case scenarios for some regions, excessive use of biochar save farmers a little more than 50% of the water they now use to grow crops. That represents a significant immediate savings to go with the established environmental benefits of biochar. Furthermore, biochar soil amendment can enhance soil carbon sequestration while providing significant co-benefits, such as nitrogen remediation, improved water retention, and higher agricultural productivity. According to an article from Regeneration International, during the production of biochar, clean and renewable energy is produced as a byproduct. This can be used as an alternative to burning fossil fuels. Producing biochar requires and creates clean, renewable energy, reducing the impact of fossil fuels.
So as we know, biochar can have a variety of different great impacts for the environment, most notably sequestering atmospheric carbon dioxide into the ground and combating climate change. However, it is extraordinarily expensive in order to implement, with the net first cost to implement a sufficient solution capable of combating climate change costing 195 to $383 billion. And furthermore, over the course of our lifetimes, the net operational savings are also negative, meaning they would cost more than they would generate in terms of economic capabilities, with it costing another 1.4 to $0.7 trillion over the course of our lifetimes. However, even though it is extraordinarily expensive, it would reduce carbon dioxide emissions by 4.4 gigatons by 2050, which does a tremendous impact in combating climate change and would prevent a variety of unforeseen costs associated with climate change, such as flooding reparations, forest fires, hurricanes, and among other things such as poverty increasing and drought and famine. And the technology of creating the biochar is easy to implement and exists worldwide, and we are technologically able to do it. We just have to do it.
So there are criticisms, though. According to Professor of Sustainable Agroecosystems Joanne Six from ETH Zurich, in some cases yields may decline because of the absorption of water and nutrients by the biochar, which reduces the availability of these resources for the crops. Biochar also has been shown to inhibit germination. The absorption of pesticides and herbicides by biochar can reduce their efficacy. Some biochars can act as a source of contaminants such as heavy metals, VOCs, volatile organic compounds, etc. The reduction in nitrous oxide emissions is not universal, and emissions even increase sometimes. Finally, long-term removal of crop residues like stems, leaves, and seed pods to be used for reduction of biochar can reduce overall soil health by diminishing the number of soil microorganisms and disrupting internal nutrient cycling. The increase in cation exchange capacity depends on the composition of the soil. It is minimal in soils with high clay or organic matter content, like this picture, especially at realistic rates of biochar additions. To recap, biochar can provide soil with beneficial properties such as CO2 containment, water storage, and increased fertility.
However, despite these beneficial properties, it is also tremendously costly and can pose risks to the environment.
Overall, more research is needed to properly assess whether the benefits outweigh the risks. This is our works cited. Thank you.
Thank you.
Thank you.